Okay, so when we walk around the sub, you can hear how it doesn't matter which direction we stand, we hear the bass equally everywhere. Well, what if we wanted to figure out how to control the direction of the bass? Well, there's this little trick that we can play. So I brought a second subwoofer out and let's turn them on. Now, I'm gonna tell the one sub to actually do the opposite of whatever the other one's doing. So if that one makes a positive air pressure wave, that one's gonna make a negative air pressure wave and vice versa. Okay, you ready? Here we go. So hear how they basically cancel out, right? So let's go ahead and add some distance between these subwoofers that equals a half wavelength at this frequency. So like this is 60 Hertz. So that means that's about just over 100 inches. So let's go ahead and scoot them apart here. How's that? Okay, so I'm gonna take this cable and I'm gonna lay it on the ground. When we hear cancellation happening, it's gonna be closer to the configuration, and when it sums together, we're gonna move further out. So we're gonna see what the pattern of the sound distribution is. So starting in the middle, because it's canceling. So like we can roughly see the sort of figure 8 pattern, right? Where we have canceling anywhere along this line, which is equidistant from the subs. If we wanted to try to pick a direction that the bass goes and cancel it all in the other direction, what we can do is actually bring the subs closer together and then tell one of the subs to actually wait a little bit with its digital signal. So we're gonna do that at 1/4 wavelength instead of 1/2, which would be about 56 inches. So let's start here with our pattern again. We obviously can hear the basses summing nicely. So basically what we did was we moved the cancellation from these two angles to this. We just scooted them back. Now, we can kind of split the difference by maybe not delaying this sub so much, either physically or with the digital delay in the signal. So I've just done that now. So if we walk over here, you can kind of tell that now the cancellation point is more right here. And then we get over here and we have a little bit more of a buildup, and then we kind of keep going. So if I were to redraw this, I'd have to take and maybe scoot this kind of like toward here. We can actually steer those cancellation spots depending on how much physical distance and how much delay we put to the signal. So the difficulty with cardioid setups is that you have to pick one frequency to build the setup around, where you have perfect summing, perfect canceling, but sound changes wavelengths with different frequencies. So the ones that are higher or lower than that, they won't get a perfect cardioid pattern.